Now, in my animations folder, I created animations for the red alien. So find your jump, idle, walk, damage, whichever alien you have, and just make sure that you highlight the node and then attach the animation clip to it. Have idle right here, motion, walk, walk, jump, damage. Cool. So now all of our nodes have our animation clips on them. What we want to do next is create parameters so that the animations transition when they're supposed to. So right here, there are two tabs, layers and parameters. So you just want to click on parameters. And you're going to check this little plus sign. That's what you're going to click. And we're going to make several parameters. We're going to make booleans and a float. So the first one that we're going to do is a float for speed. To check how fast our character is moving. Then we're going to create a boolean called isGrounded so that we can check if our character is on the ground or not. The other boolean that we need is going to be called isAlive, and that's going to check later on for when we have to restart the level or when we fall off a platform and we respawn. That's what this boolean is going to be useful for. And then the last boolean that we are going to check is damaged. That way, if we receive damage, we'll play the animation properly. Those are all the parameters that we need. And we will have access to them and make them function in the custom character controller script. But for now, all we need to do is attach them to the transitions. So the first one that we're going to do, just because it's the first one up here, is from any state to damage. So we're just going to check in the conditions here. The list is empty, so we're just going to click on the plus sign. And instead of speed, we're going to just hit this arrow and we're going to check the proper parameter that we want to add. And in this case, we want to check if it's damaged. So if if damage is true, we are going to play the damage clip. And then we're going to go to idle, the transition for, actually let's do walk first instead of jump. So from idle to walk, we're pretty much saying, so when we have speed that is greater than 0.001, we're going to play the walking animation, right? And that makes sense because if you have speed of 0, you're not moving, so you want to play the idle animation. The other thing that we need from idle to walk, we're going to check if you're grounded. Because in order to walk, you need to make sure that you're on the ground. So we're going to check isGrounded. Then we're going to go to the transition from walk to idle. And that is going to be speed is less than 0.001. And obviously your speed is going to be close to 0 or equaling to 0 when you want to hit that idle animation. And again, we're just going to check if we're grounded. Grounded is true. Now from walking to jumping, which is this arrow right here, we're going to check speed obviously is greater than 0 because we want to be able to jump even though we're moving. And we're going to check if grounded is false because we want to be able to jump when we are not on the ground. And then coming back would be if the speed is greater than 0.001 and if grounded is true. Right? So we're going to be on the ground back again if we are going to be walking. So grounded is only false when we are in the air. So that's going to apply from idle to jump as well. because we are going to be not grounded. So the speed is actually going to be less than 0.001. So it's just checking when we're not moving. And we're going to check if is grounded is true, because we are going from no motion to jumping. I'm sorry, is grounded is false, because we're going from no motion to jumping. And then the transition going back would be the speed is less than 0.001 again. And then is grounded is going to be true, going back to Alright, and those are all the parameters and transitions that we needed to set up. So now we can actually start writing the script for this. So let me just save quickly. I'm gonna double click the script. I have already written the script, so I'm just gonna briefly go through every line. Alright, just close all this stuff. Like I said, there are 2 scripts that we're going to write because we need a ground check script as well, but we'll do that after we're done with this one. So when you make the default script, you're not going to have these 3 things. If I am not mistaken, you're only just going to have using system.collections and using Unity Engine. So just make sure that you have all of these 3. And Unity Engine.scene management so that we can load from one scene to another. And again, like I explained before, this just gives us access to the backend Unity stuff. I added this require component type of audio source, and it was something that we had added in the previous standard controller. So I just copied and pasted that. Everything that is in the old script, in the standard asset script, I added as a comment on here. So just be mindful. You can copy and paste all this stuff. You don't have to retype it. However, please be very, very careful with your copying and pasting. Don't miss any semicolons. Don't miss, like, for example, the first letter of a method. Those mistakes do happen if you're not copying and pasting carefully, and it's going to throw off your entire script. And then you're going to email me telling me that your script is broken and your scene's not playing. So just be very mindful when you're doing that so that you are allocating all the lines to where they need to be, and you're not misplacing or missing anything. But in this video, I'm only going to go over the additions that I made for the script in order to make the character move from scratch. So in order to do that, I added these variables right here. So I'm going to highlight them and go over them one by one. So there are several floats that I made, public floats, so that in Editor, you'll be able to see them. And that way you can change them depending on how you want your character to move yourself. So one is called maximum speed. And that one's just going to cap the speed so that our character doesn't slide around too much. We also have another float called just speed equals to a number, and that's just going to automatically set the speed of the character's movement to 100 units. And then we need another float, which is the jump force, and that will allow us to fiddle around with the height at which the character will be able to jump. The other public variable that I made is a Boolean called grounded. I like to make it public here so that in Editor, when I play the game, I can see whether it's checked or not, to see whether the character is finding the ground or not. So it's just something helpful to have to debug. And I just called it grounded. And then I have 2 variables here that are being called privately. One is the rigid body 2D, and one is the animator. And then I call them separate things. I call the rigid body variable rigid body, and I call the animator anim. So the reason why we are getting private access to these is because they are components that we added to the custom character. We have here the rigid body, and we have the animator controller. Actually, I made a mistake here with I accidentally forgot to plop in the animation controller that we made into the controller slot. Oh, I have two custom aliens. Okay, let's just, it's this one. Alright, so I just added it by double clicking. Whoa. Did I double click? No, actually I did the little wheel. So just make sure that it's the proper animation one. This is the one that we just edited. So just make sure that your controller is the one that you were fixing up. Okay. Now we can go back. So it gives us access to the rigid body, like I said before, which is on the custom alien game object, and also the animator controller that we just made, which is this. So the script's getting access to it. And that's pretty much it for the new variables that are going to make it move. Everything else down here we have done already. Okay. So there are two lines that I added in void start. This is setting those variables that we have, that we just made up here, the private variables. I'm just setting them so that Unity knows exactly what it's looking for. So by saying rigid body, which is our rigid body right here, the variable, by setting it equal to GameObject.getComponent rigid body, I am telling Unity within the game object that this script is attached to, which is the character controller, right? This is where our script is. I'm telling Unity to find the component of rigid body and call it rigibody. And it's going to find again the animator, and it's going to be called anim now. That's really what that means. It's easier by setting up these variables to and telling Unity to find them. It's just easier when we start setting things up so that we don't have to write all of this stuff at the same time. So a good explanation of that would be here in void update, where I have added all this stuff. If I hadn't used anim .set bool in order to set this entire line, I would have had to use this whole thing. So let me just demonstrate it by copying that and pasting it right here. Right? It's just a lot of stuff to type, and it's just not necessary when by calling it anim you're doing the exact same thing, just shorthand. So that's why we set up these variables to be called these two different things. So in update here, I set the boolean, which we had called is grounded, and the float, which we called speed, which is they're in here in the parameter of the animator, speed and is grounded. And I'm just setting them up to mean something. So the grounded is going to be referring to this boolean up here that's going to check whether we're on the ground or not. And then speed is going to be this math function of rigidbody.velocity.x. So I'm going to be looking at how fast I'm moving on the x-axis, and it's always going to be the absolute value. That's what mathf.abs means. This is good because, for example, when you are moving left, you're going to be reaching x equals 0 and x equals a negative number. So we don't want our speed to be affected by moving in the negative number. So we want to still move even though it's negative. That's why we use an absolute, because even when we are negative, the math function will make that number into a positive always. The other variable that I created here was a float h that I set to input.getAccess horizontal. And what this does is get the input of the keyboard with the left and right arrow. The reason why the horizontal string works in here, let me go back to Unity really quickly. In Edit, Project Settings, Input, this is where we can set up all the keys and all the buttons and allocate them to axes that Unity has. So the horizontal axis is right here. So if I expand it, I can look at the negative button, which is the left arrow, and positive button, which is the right button. So that's getting input from those two keys. Alternatively, you can use A and D as well. So for those of you who play games using WASD to move around, you can actually move your character with A and D. But it's helpful. You can, obviously, you can change these buttons around, but it's nice to have it all pre-done for us. So that's what we're getting here, input.getAccess horizontal. Now, this if statement is very important because we want the character to be able to look at the proper direction when we're moving it. So it's this line and this line that does that. However, this line is looking at when you're moving left. So we are flipping the entire game object on the x-axis when we are moving left. And you'll see in a minute, well, not in a minute, but when I'm done with the script and we actually implement it on the character, you'll see why that's important. So just make sure that it's that negative number right here within the first coordinate of vector 3. Again, vector 3 is x, y, and z. Now, please pay attention to what I'm going to say. So this number right here, 2.8, is the scale of my character when I made this in the scene that we did in class. However, the scaling should be different now because I just plopped in a new alien, the red one, and the scale's not going to be the same. So this is what you need in order to fix this. You're going to highlight your character and you're going to check the scale right here. Right here, mine says 2.2328. I'm not going to type in the whole thing. I'm just going to do 2.2. But be mindful, these scale numbers on all of your 3 axes, they need to be identical to the ones that you have in this script, or else it's just going to be different. Your character is either going to be too small or too big. So it's no longer 2.8 for me, it's 2.2. So I'm going to be changing those. So please change your scaling to however big your character scale is in the transform. I'm also going to do it down here. I know that we haven't gone over this just yet, but we will in a minute. Alrighty. So, yes, so that's what this if input get access horizontal means. So we're saying if we are touching the left and right arrows and our speed is less than negative 0.001, then we're going to flip our game object on the x-axis on the negative side. That way our character is looking left when we are moving left. And this line is the most important one because it's actually going to allow us to be moving on the x-axis. So we are telling the rigid body to have a force in the vector 2 position, vector 2.right, times the speed, which is the variable that we had created up above, times h. So we are giving ourselves, we're telling the rigid body to move in a certain direction times the speed, and we're allocating all of that to our input so that when we are touching those arrow keys, we are going to be moving. Now, when we move to the right, which is exactly what this line says, if our input on horizontal in the left and right arrows is greater than 0.001, if it's in the positive, then we are going to leave the scale as is in the positive realm, right? So when we move to the right, we are facing right. This debug line you do not need. I was just checking for something during class, and you don't need that. Make sure that you are putting your end curly brackets in your if statements. Okay, and here's the functionality for jumping. So we're saying if the input of the key of space is pressed down, if the space bar is pressed down, and if we're grounded, if we're touching a platform, then we're going to add force on the y-axis, which is vector 2 up times the jump force, which is the amount that we're going to be able to jump, which we also had created a variable for up above. So that's what that means. And here I commented the jumping sound effect. So just copy and paste that from the previous standard character script that we have been editing. And again, also all this stuff was from our previous script. All right, and that's pretty much all you need for moving. The fix update stuff that's right here, it's going to prevent our character from sliding around. You can check it yourself. You can just save the script up to where we finished it, up until the input get key space, get key down key code dot space. You can try to see how your character moves with just these lines of code. But it is going to slide around. And that's why we are going to add this little bit of functionality. So let me just do the rest of the video in a third part.